Okay. And we want to distinguish between sex determination and sex differentiation. So we said sex determination was dependent upon the presence of the SRY gene, right? So the Y chromosome, which has the SRY gene, which codes for some specific proteins. So if we have XY, meaning we have the presence of a Y chromosome, this is going to be male. And that is going to lead us to the Y chromosome having the SRY genes, which codes for TDF. Remember, TDF standing for testis determining factor. And that would eventually produce testis development. Okay? And remember, testes are going to produce testosterone. Once we start getting those Leydig cells, they're going to produce testosterone. Sex differentiation was when that testosterone started to develop the Wolffian duct structures. I'm going to list them here, but the penis, the vas deferens, the scrotal sac, all of those are the other accessory, the prostate, the seminal vesicles, are the other structures that are going to differentiate from having the Wolffian duct structures progress under the influence of testosterone. Okay, so you can make a note of some of those structures somewhere on your sheet. If this testosterone is present, we're also going to have MIH. That stands for Mullerian inhibiting hormone, and that is going to cause the Mullerian duct structures to regress. Okay, so this is why we kind of think that the default is female, because if we don't have this hormone, then we kind of develop both sets of organs. That's what hermaphrodites kind of have, both sets of organs or a combination. And so the Mullerian inhibiting hormone is just as important as the testosterone in terms of developing the appropriate structures. Now, if we don't have testes, what happens is the Mullerian duct structures develop. And the Wolffian duct structures regress. Okay, and some of the Mullerian duct structures here are the uterine tubes, the uterus itself, the vagina, etc. The other parts of the uterus as well, the ligaments, etc. So if we don't have testes, we don't have these hormones, and then the opposite happens in terms of the development. So that's kind of the difference between sex determination there and sex differentiation. Let's look at the cells. Actually, let's look at a new chart here. Let's look at the reproductive cells and what they produce. We'll look at the cells. What hormones influence these cells? And then the feedback mechanism. Okay. So we start off with the Sertoli cell in males. This is going to produce two things, testosterone not testosterone, excuse me, inhibin. And then its other function is that it is influenced by FSH to produce this inhibin, as well as to help with sperm development. It's also influenced by testosterone. Okay, that testosterone coming from the Leydig cell. So I'm going to put Leydig here. So Sertoli cells secrete inhibin. They're influenced by FSH and testosterone, which comes from the Leydig cell. They're also going to have a negative feedback onto FSH production, as well as a negative feedback onto LH production. Okay. Let's look at the Leydig cell. Also mentioned here, this is the cell in the seminiferous tubule, whereas this is the cell in the interstitium. Right, so it's off in the periphery. This produces testosterone, the Leydig cell. It's going to be influenced by LH, and it is going to have a negative feedback, again, onto both of these hormones, LH plus FSH. So remember, the testosterone negative feedback is going to be not only in the hypothalamus, as well as the anterior pituitary. Okay, so that was males. Let's look at females and the cells and functions there. So females have the granulosa cell. This is a part of the follicle, right? That is going to secrete estrogen, not estrogen, inhibin, and that is also going to be influenced by FSH. Remember, we said the granulosa cell is very similar to the Sertoli cell. It's going to have a negative feedback onto FSH production from the anterior pituitary. There's also the theca cell. We didn't speak a lot about this, but it's also a part of the follicle. And this is being influenced by both FSH and LH, and this is going to secrete estrogen as well. Okay. And that's going to have a dose-dependent negative feedback. Remember, there was a time in the cycle where the negative feedback of estrogen was a positive, the feedback of estrogen was a positive feedback cycle onto the anterior pituitary. This is what produced the LH surge, right? So this is going to be dose-dependent. It's going to be negative or positive, depending on the time of the cycle. It's going to be positive for ovulation to occur, and then negative otherwise, okay? So we'll put dose dependent here. Alrighty, and then last we want to mention the corpus luteum, because this is kind of like a cell. It's the tissue that continues to produce estrogen and progesterone towards the second half of the cycle. Remember, so the corpus luteum takes over the estrogen production, and it's also going to produce progesterone, which kind of comes into the picture in the second half of the cycle. This is under the influence of the luteinizing hormone, and it has a negative feedback onto FSH and LH, okay? Again, this is, both of these feedbacks are going to be onto the hypothalamus and the anterior pituitary. Okay, so we can see how the cells of the female ovaries are very synonymous with the cells of the testes in terms of their function, the way they have that feedback cycle. The only difference is that in females, we have a much more complex cycle happening with the different phases of the uterine and ovarian cycle. Okay, oops, can't see this. There we go. Let me double check here and let's see if there are any questions. Okay. Now, is there anything else that you guys would like me to go over, like in terms of yesterday's content or today's topic? I just want to be mindful of anything that you guys may be having difficulty with as I do this review. I'm going to take a second here and see if there's anything. I'm going to look at one last kind of table here. Okay, now there's two more things I want to go over, and just briefly, because we've talked about this a lot. The phases of the male sexual response, and then just briefly looking at the different parts of the ovarian and uterine cycle. So first off, we have the 3 phases of the male sexual response. There's erection. This is controlled by the parasympathetic system. This is under the influence of the mechanoreceptors. So the mechanoreceptors are the initial stimuli here in erogenous zones. Okay, and here we had the erectile tissue of the penis becoming engorged. The second phase was emission. This was under the sympathetic. This was where we had the movement of sperm from their storage area in the vas deferens into the urethra. And here we had the addition of secretory fluids from the accessory glands. So we also have secretory fluids from the prostate, from the seminal vesicles, as well as the bulbourethral glands. Okay. And then finally, ejaculation. Also under control of the sympathetic nervous system. This was the movement of that semen. So the fluid is now called semen when we add these fluids to the sperm. Through the urethra and into the female reproductive tract. Okay, so kind of important parts here is understanding which division of the nervous system and kind of what's happening in terms of that phase. Okay.